Okay, so in this little video, I will show you how, with two formula, we get 6 of them in dynamics for the kinematics of a particle in rectilinear motion. So we have two formula, A equal dv divided by dt, and v, the velocity, equal ds, dt. Okay, so this one is between acceleration and velocity, and the second one is between velocity and position. And remember that each of them are vector, two dimensions for displacements in 2D and 3-dimensional displacement in 2D. From those two formula, what can we do? We can play with them. So the first one, let's call it this one the first, and this one the second formula. The first formula, I will switch dt. So I have a dt equal dv. And after that, I will just keep dt on the left. So dt equal dv divided by the acceleration. Now I use the second formula, and I will do the same. So I have v dt. I switch dt on the left equal ds. And now I will keep only dt on the left, dt equal ds divided by the velocity. Okay. Now I will merge those two equations. Dt equal dt. So dt equal dt. So dv divided by the acceleration, it's equal to ds divided by the velocity, right? And one last steps, I will switch v on the left and a on the right. So we have v dv equal a ds. There we go. That's how you get the relation. Now we have the relation. So those two first were acceleration and velocity and time. And this one and time. And this one, there's no time anymore. We just have velocity, acceleration, and position. So you see, this formula is just a combination of the two first formula. Now, with those three formula. So let me write the three formula again, because I will switch to the right. So we have A equal dv divided by dt, v equal ds divided by dt, and the last one is v dv equal a ds. Okay. Now with those three formula, okay, I will find the formula. That's the general formula for any type of acceleration, velocity, and displacement. I will find for the formula for constant acceleration. Okay. So we have A, now A, it's equal to AC with the C like constant. Okay. So we can write that A constant equal dv divided by dt. Okay. Oops. So we have AC dt equal dv. And I will take the integral on both sides. So on the left, AC dt give us AC time t. Let's say it's between t and 0. So between t and 0. And on the right, it's between 0 and v. Not 0, v naught, and v. And it gives us v of t minus v naught. V naught is the velocity, the initial velocity. So we can write that the v of t, so we have AC time t plus the v naught equal v of t. Here we go. That's how we have the formula for the velocity if we know that the acceleration is constant. Okay. Now let's use the second formula, the formula v equal ds dt. Okay, so we have v equal ds divided by dt. So we can write that v times dt equal ds. And we can take the integral of both sides exactly like we did. But now we will use the formula for v, this one, the general formula that we found for constant acceleration. So we have the integral of AC t plus v naught dt. It's equal to the integral of ds. This is between 0 and t. Let's see if we begin at t equals 0. And between the initial displacement s naught to any displacement s. So we need to take the integral of this one. So we have AC t square, no, let me go do one step at a time. AC, yes, t square divided by 2 plus v naught times t, and this is between 0 and t, so that's only this. And it's equal to s of t minus s naught. ds is just s. So we can write that AC times t squared divided by 2 plus v naught times t plus s naught equal s of t. So we have the formula for any displacement if we know that AC is a constant acceleration. Okay, so now that AC is constant, v naught is the initial velocity, s naught is the initial displacement. The only thing that changes is the time. Okay, and now we have the last one. We will use this formula. Let me go to the right. Okay, I want to have enough space. So we have v dv equal a ds. And we can take the integral of both sides. Okay. On the left is the integral of v. So about v. So it's from v naught to v. And on the right, it's the little element of integration is ds. So from s naught to s. Okay. The integral of v, it's v squared divided by 2. And it's between v and v naught. So minus v naught squared divided by 2. On the right, a, it's constant, so it's ac, and it's between ds, so the integral of ds is s of t minus s naught. So we can rewrite this. This one is v of t. This one is a function. So we have v of t, let me add some brackets, divided by 2. It's equal to I want to write it the same way, v naught squared divided by 2 plus ac time s of t minus s naught. Okay, and I will switch the 2, so we have v of t square, it's equal to v naught square plus 2 times ac times s of t minus s naught. And that's your formula. So what is constant there is your v naught. It's given, it's your initial velocity. Your acceleration is constant. You have your s naught. And you are able to find for any position s. So what you will have as information is you will have the position s, and what you will find is the velocity v. You can take the square root of all of that. So most of the time, s will be given, and v you will have to find it. Or maybe v is given and you need to find the displacement. But you see all those formula that you have on your little formula sheet. Let me see. Try to have everything on one page. Here we go. They are all coming from only two formula. A equal dv divided by dt and v equal ds divided by dt. They are very powerful, right? That's it. Bye-bye. See you soon.